So let's just unpack this right away. Imagine for a second that you are building a house.
Okay.
You have this detailed blueprint,
Right.
Architectural drawings. And you have a contractor. In the old days, you'd hand that blueprint over, they'd go off to build a wall, and if they change something...
Like moving a window.
Right. Say they move a window 6 inches left because of a pipe you didn't know was there. You would just literally pray that they took a red pen and mark that change on the blueprint.
Which, let's be honest, rarely happens.
Exactly.
The house gets built, the blueprint stays rolled up in a corner somewhere, and by the time you get the keys, the map definitely does not match the territory.
And then it's just physical construction. Now, fast forward to software development today. We have these absolutely incredible AI contractors now.
Tools like Cursor, Copilot.
The models powering them. We tell them, build this feature. And they do it lightning fast. But here's the massive problem we're tackling today. The blueprint, our documentation, our specs, it just gets left in the dust.
Yeah.
The AI changes the code autonomously, but the docs don't magically rewrite themselves.
And that's where the chaos creeps in. It's what we call drift. And in software, drift is expensive.
So expensive.
You end up with a system where the code does one thing, the docs say it does another, and nobody, not even the AI, knows the actual truth anymore.
So today we are diving deep into a concept that supposedly solves this. Spec-Driven Development.
Yeah.
SDD.
Right.
But we're looking at it through a very specific lens. We're analyzing a deep dive into a Q&A session with an expert developer named Alvaro. And he's demonstrating this framework called OpenSpec.
And our mission here today isn't just to talk about keeping your folders organized.
No.
If you think this is about file organization, you're entirely missing the point. This is about money and speed.
The ROI.
Exactly. We're going to explore how using a framework for your specs can drastically save on AI token costs, and how it allows you to maintain incredibly high standards, even in bilingual environments.
So let's jump right into the magic of synchronization, because this is the big promise of OpenSpec.
It is. And to really grasp the solution, you have to feel the pain of the problem first.
Right.
In the source material, there was this listener, Christian, who brought up a super relatable issue. He was actually trying to do spec-driven development on his own.
He was trying his best.
He was. He was defining his designs in basic markdown files, and then using Cursor to build the code based on those files.
So he's already ahead of like 90% of developers.
True. But he said that when he let Cursor make autonomous improvements, letting the AI improvise to fix a bug or optimize something, the specs just weren't updated.
The blueprint is wrong again.
Precisely. The code improved, but the documentation remained entirely static. And this is where it gets really interesting. Alvaro admitted he tried to build his own homebrew version of this workflow before he adopted OpenSpec.
Oh, right. He had that script set up.
Yeah, he called it Enrich, Plan, Develop, Update Docs.
I mean, that sounds incredibly logical to closed loop.
It sounds perfect. But he noted it failed in a very nuanced way. His manual scripts could update the data model. Like if the AI added a new database table, the script caught that structure.
Okay.
But it completely failed to track the delta.
A delta. Break that down for us in this context.
The delta is the small, specific changes requested during the back-and-forth conversation, the nuance.
Right.
For example, imagine he had a task open to create interview. Midway through coding, he tells the AI, hey, actually, add this one specific validation field for the date because of a business rule.
Just a slight pivot.
Right. The code gets updated, the validation exists. But his manual system couldn't capture that conversational shift back into the docs. It didn't record why the change happened.
So the final documentation is missing the actual story of the decision.
Exactly. And that is where OpenSpec introduces its core mechanism, the apply command. This is the magic button.
I do love a magic button. Walk me through it. I'm coding. I've argued with the AI. The bug is fixed. I hit apply. What happened?
It doesn't just save the code. It manages two critical folders, the archive and the specs.
Okay.
When you run apply, it looks at the work you just did. It updates the documentation in the specs folder to reflect exactly what tasks were done and what remains.
So it's treating the documentation as a living entity.
A living entity that traces the exact history. Whether it was a one-shot success where the AI got it perfectly, or if it took 5 iterations of debugging, the apply command records that history.
That's huge. Because usually docs are what you do at the very end. It's Friday afternoon, you're exhausted,
Yeah.
and you just think, I'll write the docs next week.
And next week never comes.
Never.
Which is why keeping the blueprint updated isn't just about being neat. It leads directly to token economics.
Ah, token economics. The cost of doing business with LLMs.
It's the currency of the AI age.
We had a question in the source from a listener about optimizing tokens. And just to baseline this, tokens are basically what you pay the AI. Every word you feed it costs a tiny fraction of a cent.
But those fractions add up incredibly fast.
Oh, yeah.
And here is why undocumented code chaos essentially is so expensive. If you don't have specs and you ask Cursor to fix a bug, what does it have to do first?
It has to read the code to figure out what's going on.
It has to scan the entire code base. We are talking potentially 10,000 files just to understand the patterns and variable names.
That sounds like a massive amount of tokens.
It burns a brutal amount of input tokens. That was Alvaro's word, brutal.
It's like hiring a consultant, making them read 20 years of company emails before answering one question.
Highly inefficient. But the spec advantage is that by pointing the AI to the specs folder, which might just be 7 specific markdown files, the AI understands the system immediately.
Because it's a tiny footprint.
Right. And that data is often cached, drastically reducing investigation costs. But there's a tactical tip here that I thought was brilliant for managing context windows.
The two-window strategy.
Yes.
Walk us through how this works in practice. I think this actually changes how people work day to day.
So imagine you have a complex task. Step 1 is the thinking or planning window. You open one chat window. You run the planning commands. In OpenSpec, this is the FF or fast forward phase.
You're just generating the plan.
You're going back and forth, refining it. Now, by the end of that session, the AI's memory, the context window is getting pretty full.
Right. He said it gets to like 60% full just from planning.
Exactly. Now, if you start coding in that same window, you are dragging all that conversational baggage with you. You're paying for that 60% usage over and over with every new prompt.
So what's the move?
You open a fresh, empty window for the implementation.
But wait, doesn't the new window need to know what you just planned?
It does. But because the first window generated the documentation and saved it to the specs via the apply command, you just go to the new window and feed it that specific task.
You just pointed to the spec.
Yes. The AI doesn't need the conversation history of how the plan was made. It only needs the plan itself.
That is so smart. Strip away the noise.
And the results are stark. Alvaro noted he completed 95 tasks using this method, and his context usage hovered around 59%.
Proving that separating definition from implementation saves massive amounts of tokens.
Significant tokens. Which brings us to the actual ROI.
Right. Gerardo asked about the price tag of these tools.
It's a very practical question. For context, basic licenses for Cloud Code or Copilot range from $10 to $20 a month.
Which is fine for learning.
Fine for learning. But the max license, the one that gives you the really powerful, fast models, is around $100 a month.
Which sounds steep for a text editor subscription.
It does. But Alvaro had a warning for managers here. If you see developers burning through that $100 limit and hitting quotas, it usually indicates bad usage.
Really? I would have assumed it meant they were just working super hard.
Not necessarily.
Oh.
It means they are systematically exceeding quotas because they aren't using spec-driven techniques. They're dumping the whole code base into the chat over and over.
The chatty workflows instead of structured commands.
Exactly. But let's look at the payoff. My favorite quote of the entire session was when Alvaro said the $100 license was paid off in minute 3.
Paid off in minute 3. That is a wild claim.
It is. But look at the example he gave. He completed 5 major tasks: create interview, visualize, edit, delete, and update positions.
A full feature set.
Yes. In 2 afternoons.
Wow. 2 afternoons for what used to take maybe a week or 2.
Think about the hourly rate of a senior developer. Saving 2 weeks of work pays for a $100 tool in minutes.
It's a force multiplier. But there's another layer to this efficiency, and that's the language aspect. We have to talk about the bilingual challenge.
This is crucial for global teams. The listener asked about coding in English versus Spanish.
Because Spanish was his native language.
Yeah.
And the AI understands Spanish perfectly.
It translates nuances beautifully.
So why not just code and document in Spanish?
Because of the global code rule. Alvaro was very firm here. Even if your whole team speaks Spanish, the output, the code, the specs, the commits should always be English.
To ensure it meets global quality standards.
Exactly. You don't know the nationality of the team inheriting this project in 2 years.
Right.
If half the variables are Spanish and half are English, it creates massive friction.
So how do you enforce that without constantly typing, hey, please translate that back to English?
There's a specific configuration tip for Cursor. You can instruct the AI in your settings no matter if I talk to you in Spanish.
Yeah.
You always answer, write code, and document in English.
It effectively acts as a real-time translator. You speak naturally, the code comes out standard.
And this connects directly back to reliability. Alvaro talked about reducing indeterminism.
Indeterminism. Break that down for us.
Generative AI is by nature unpredictable. Generative. You ask a question twice, you get two different answers.
Right.
That's indeterministic. But software engineering needs to be precise. By using specific commands /new/ff/commit/apply rather than open-ended chat, the workflow becomes deterministic.
You're relying on systematic scripts instead of the AI's creative mood.
Exactly. Now, I know what listeners are thinking. This all sounds great if I'm starting a brand new project.
The greenfield projects.
Yeah.
But what if my code is already a mess?
The brownfield projects. Wilfredo asked this exact question. Is it too late to adopt SDD?
And what's the verdict?
It's surprisingly simple. Alvaro walked through the setup. Step 1, run spec in it in the existing project. Step 2, select the IDE. Step 3, restart.
Okay, but the tool doesn't know your messy legacy code yet.
Right. The critical step is updating the config.yaml file, but you don't do it manually. You prompt the AI to fill the config with technical context, pointing it to your existing code standards.
Use the AI to explain your old code to the new framework.
Exactly. He gave a great Python example. He took a generic backend standards file that was originally for Node and JavaScript,
Okay.
and he just prompted the AI update backend standards knowing I work with Python.
And it automatically adapted the specs.
Instantly adapted them to the existing code structure.
That is incredibly flexible. You spend 10 minutes setting it up and save hours of confusion later.
Absolutely.
So, bringing this all together,
Yeah.
OpenSpec isn't just a file organizer.
Far from it. It's a bridge on one side, human intent on the other side, AI execution. It saves money and ensures traceability.
And as these tools get more powerful, it really highlights that the process of how we manage the AI is becoming way more important than the prompt itself.
Process over prompt. That is the massive takeaway here.
Before we sign off, I want to leave you with a lingering thought. We talked about how the specs folder is constantly kept alive and accurate by the AI.
All right.
Well, if that's the case, will we reach a point where the changes folder eventually becomes the only necessary summary of the entire project?
It's a great question.
Like, does this render traditional manual documentation completely obsolete? Something to mull over as you work this week. Thanks for joining us on this deep dive.
Catch you next time.